For our second problem, we've got an IR again. We want to draw our lines as carefully as possible at 1500 and 3000. You can use the edge of a page, edge of a desk to make sure that line is straight. What do we see? We see our sp3s to the right of 3000. We see this bit here, that's more sp3s. That's not an aldehyde signal because we would see a CO double bond in addition to what we see here. How do I know that's not a CO double bond on the left of 1500? Well, it's because I see the characteristic triple dip here of a primary amine. And whenever you have a primary amine, now alcohols, OHs are nice and smooth in that region. Amines that are primary, that have one hydrogen might appear more smoothly than that, but primary amines are very clearly a triple bump there. And they also give an NH2 bend. This is a bending mode versus the stretching mode in and out of the individual bonds on the hydrogen of an amine. Okay, so a bend versus a stretch, and whenever we see NH2 stretch, we expect to, for a primary amine, we expect to see that NH2 bend. That applies to amides as well. Amides would also have evidence of a CO double bond in that same type region, maybe even a little bit over to this side actually for amides. Okay, but to the left of 1500. This is definitely an amine. If we didn't know that, we would be left at a disadvantage trying to pick the molecular ion between 59 and 58. And so because we know the nitrogen rule says that an odd number of nitrogens in a compound yields an odd numbered molecular ion. So this is M+. The other way we could figure that out is we could say, okay, so 58 and 59. If 59 was an M+1 peak and not the molecular ion, it's about 3/9. It's about 33% of the signal. So 59 is 33% of 58. Okay, so 59, if we're considering that 58's 100% and 59 is 33% of 100%, it's too big. 59 is too large to be an isotope peak because at 58, if we do 58 divided by 13, we're only allowed to have 4 hydrogens or 4 carbons in this molecule. So C4, 1.1% of all carbon is carbon 13. 4 of them means that this peak at 59 can at most be 4.4% if it's due to carbon 13 alone. Since it's not 33% and not 4.4%, it can't be just due to isotope effects. So it has to be the molecular ion. And because we see nitrogen in the IR, we're pretty confident that we are on the right track. So that leaves us with even fragments, most likely, and there we have even fragments, and that is an M-15 peak or loss of methyl. And that's really, if we're going halfway down the spectrum, this is the one group of signals here, and here's the largest in that group of signals. It's really the only one that we see that really stands out. And so let's figure out the molecular formula. Well, we know there's a nitrogen, so we have 59, nitrogen weighs 14, and that's going to give us 59 minus 14 is 45. Divide by CH, divide by 13. And we get 3. So C3, H3, we need to add some in because of a remainder, and then nitrogen. So how much do we add in? Well, we say, okay, well, 3 times 13 is 39, 45 minus 3 times 13, 45 minus 39 is 6. So this ends up being C3H9N is our molecular formula. Does that make sense? 1 plus the number of carbons plus the number of nitrogens over 2 minus the number of hydrogens over 2. Oxygen doesn't count. There is no oxygen anyway. So 4 minus 4 is 0 degrees. That makes sense. That can happen. If degrees of unsaturation are negative, not whole numbers, then our molecular formula is wrong. If there's more degrees of unsaturation than there are carbons, we're probably wrong in our molecular formula. So what could this compound possibly be? Well, C3, and we know for a fact we have an NH2 from the IR. The IR gives us that information directly. So we either have 3 carbons in a row, or we have the amine in the 2 position. That's the only 2 possibilities we have. So we go to our knowledge of amines that do alpha cleavage, and we know that this amine would yield an M-29 peak for loss of ethyl, and the lower isomer, ionizing the lone pair, meet in the middle, homolytic cleavage, in both positions would form an M-15 by alpha cleavage. Loss of methyl there. So we know for a fact that is the isomer that we have because of the huge M-15 peak.